Hi, welcome back to Computer Programming in Scratch. I'm Mr. Wilkerson, and today we're going to do Scratch activity number 9, and today we're going to try to wrap up our series on linear equations. Let's review very quickly what we have learned so far. We have created subroutines, 4 of them so far, to help us determine everything we need to write the equation of a line that is defined by 2 coordinate points, x, y coordinates. All right? And our first subroutine is, I've called it get coordinates, and that makes use of creating lists. Okay, here we've got variables and lists can hold more items than a regular variable. But we've created 2 lists, one that will hold our x coordinates and one that will hold our y coordinates. And so it gathers the information. The user will input that information, and that's where it all starts. It starts with knowing the x and y coordinates for 2 points in our Cartesian plane and on our graph paper. Okay, so what is the x coordinate and the y coordinate for the first point, and then the x and y coordinates for the second point, and it puts them in a list. All right, so if I run this, I can say, well, my first coordinate, x coordinate, let's say 6 and then 3, and then the second point, let's say -4 and -5. Okay, and so we have our 2 points, 6, 3, and -4, -5. And those are in our list. Okay, so that has gathered our data, and there we go. Okay, now I was looking and I had noticed that some of my lines of code had wound up in a different subroutine. These 1, 2, 3, 4, 5, 6, 7, 8 lines of code, or blocks of code, somehow found their way into my finding slope subroutine. So I took them out and brought them back up here. And what I've done is I've created the variables x1 and x2 and y1 and y2, and populated those variables, set them equal to the number of the item that's in the list. So in my x coordinates list, x1 became the first item, and x2 became the last item, because there were only 2 items. And the same for y's. y1 became the first item, y2 became the last item. Then I just reported out 1 point on our line is item 1, so x comma y, and 1 point on our line is last item, or item 2. And then it hid the list, so let's watch that again. Alright, so this is just simply gathering that data. So let's just create a point 6, 3, and -5, -5. Okay, so 1 point is 6, 3, and 1 point is -5, -5. Alright, so that's it for this subroutine. It just gathers the data, puts it in variables, puts it in a list, and then from the list puts it in variables, and reports it out so that we can verify that we have entered our data correctly. Alright, and then so our next subroutine is the one where we find the slope. All right, we explain what the slope is, and we compute that or calculate that, and then report it out to the user. Okay, because that's what we want this to be useful. Okay, so we put in the coordinates, and all of a sudden, boom, instead of having to do all the calculations ourselves, our Scratch program does it for us. Okay, it's more work to put the computer program together, right? But for someone else, if we were to give this to our algebra teacher, then they would be able to use it, or anybody else, to find the slope of a line for their homework, or for whatever reasons they may have to do that. So here we have our finding slope. It says, now we will compute the slope of the line. The slope is the change in the y over the change in x. So we're going to determine the change in y, or the rise. And we created the variables change in x, change in y. And we set change in y to be y1 minus y2. And we set our change in x to be the x value, the difference, or subtracting the x values, and just reported that out. Okay. So that's what our defined slope is. Let's run that. Let's see what it does. Now we will compute the slope. Sorry, there's another class in here. Slope is defined as change in y. Let's determine the change in y. First we subtract y1 minus y2. Or in other words, 3 minus a negative 5 equals 8. Let us determine the change in x. x1 minus x2. Or in other words, 6 minus a negative 5 is 11. Alright, so it told us the change in x and the change in y. I suppose that probably would have been a better name for our subroutine, would have been determining change in x and change in y. Because down here is where we will report the slope, or find and compute and report the slope. Our third subroutine, where it says the slope's defined in a few different ways. First is a fraction, and it reports out change in y, which was the subtracting those, over, puts a little fraction slash, and reports it in a fraction, and says m, which is our slope, the designated slope variable name, is the change in y over the change in x. Then we have a variable that we called slope decimal, where we calculated the slope to be the actual decimal value, where we do the division. The change in the y values divided by the change in x values, and then just say m equals whatever that is. It'll be different for whatever 2 points we put in. And then finally, we find the y-intercept. We learned in our last lesson to find the y-intercept. We multiply the slope times an x value, and then subtract that from a y value. And then that spits all that out. So this is really a pretty in-depth and hardy set of code that we've done here. And most of the work has been done. Now, really all we want to do is to report out the linear equation for this line, the equation for this line. Okay, so I could either just tack it on to my main code or create another routine, subroutine. I kind of like doing that because it breaks it down to manageable chunks, so that you can, if something goes wrong, you can always, narrow it down to a certain area. Okay, and that's why we have our documentation here that explains what each thing should be doing. Alright, and that's what we have over here too. At the end, after we show our line, or the equation for the line, we can get rid of these things and our program will seem a little more magical. So let's create a block and let's just call it writing the equation. Writing the equation. Alright, and it's going to ask us to define that. Okay. This is really just going to be taking our, we're going to have our sprite tell us what the equation is. So really, I think I'm creating a subroutine for this is really kind of silly. But there's always more than one way to do something, so we'll just keep the subroutine, and this is as silly as it seems. And so we're going to use our variables, and we're going to use our operators. We better throw out some joins here to so we can say everything we want to say. Alright, so we're just going to have it tell us the equation for the line is. So let's see here. So, comma, space, the equation for the line is, you know what, I'm going to put that here just to make things a little more complicated. Let's copy that and put it up here. Paste. So the equation for the line is colon, and we're going to make it say that for maybe 3 seconds. Yeah. Okay. And so then let's pull out another say, and let's start putting this together. So the equation for the line is, or no, we've already said that. We want it to say y equals, and that's where we manipulate our variables and our text and put them together in such a way that it looks good for the user. So if your homework was to write the equation for the line that is defined by these 2 points, 6, 8, and negative 5, oh, here it is, 6, 3, and negative 5, negative 5, then we would say, okay, so the equation for the line is y equals, now we're going to put the slope, which is, we could put it in fraction form first, which is y equals space change in y, then a space, a fraction bar space or slash, then change in x. That gives us our slope. Oops, I need to put a join in there. Change in x. Then put the join in there. Sorry, there's another after-school program coming in here. It's going to be, so y is equal to the slope, which is change in y, over change in x, then plus space plus space the y-intercept. Hi! Doing okay. And so I'm going to put this into my, let's see what that says. Alright, because it's still holding on to my information here. Equation of the line is y equals 8/11. Oh, you know what we forgot? Duh. Okay. Let's see if you notice what's wrong. Y equals 8/11 plus a y-intercept. Put that on as $4 sign. Now there is something missing because things should be in the form of, should be change in y, so the slope it should be times x. So we're going to put x here, just x. So the slope x, and then space plus space, the y-intercept. That should be a little better. Let's try that. So the equation for the line is y equals 8/11 x plus the y-intercept. I'm going to make that worth 5 seconds, and I would really feel better if my x were in parentheses. Actually, we should have our slope in parentheses. That's going to take too long, so I'm going to go parenthesis x parenthesis. Now let's check it out. So the equation for the line is y equals 8/11 x plus 1.8. Still think that should be a little longer. And that's getting we've gone through all this work now, the last 4 activities, to get it to write the equation for the line. Now, we could write it in another form here too. We could say, remember, we could say or, then have it say, let's take all this stuff and duplicate it, put that in there, or y equals, and let's just put the slope decimal, okay, in there. The slope decimal x plus y-intercept. Let's see. So the equation for the line is, we have our slope in fraction form here, 8/11, and 8/11. Thinking about this, okay, change in y values, yeah, and change in x values. So I missed it. I was too busy thinking I had done something wrong here. The equation for the line is, we'll have our first one in fraction form, 8/11 x, and there's the y-intercept, or, this is quick, fraction form, decimal form. Alright, so I'm going to just go ahead and put this as 6 seconds also, and we should probably wrap things up by having our character walk out of here, or ask us if we would like to do this again. Do you have 2 more points? So, but that's what I'd like for you to do, is to go ahead and write the code that will give us the equation for the line, and finish up your project this way. And I'd love to be able to report back to your math teacher that you are doing some really good work here. We can't forget, of course, what I've noticed is that some people are forgetting to add the blocks over into our main program. Have a good day. And so now it should work.